Hello everyone, and thank you for your time today. So the focus of my presentation is accelerating development, improving reliability, and managing costs in all aspects of the development process in this disrupted era that we encounter today. Okay, I'll be speaking about the development of autonomous systems for the automotive and industrial markets, but I would like to point out that the principles and the points that I make today could be applied to many different industries. So let's start by taking stock of the state of the automotive and related industries today in the light of the recent disruption. So of course we have a lot of negative disruption. We have reduced sales in all segments. We have notable suspension of self-driving programs, and that leads to reduction in available R&D budget and many other constraints on companies developing products and technologies in the market. It's not all negative, however. We've seen high-profile uses of autonomous vehicle technology in China and other regions for the purposes of food, medical delivery. We've seen automated street cleaners, security vehicles, and robo-taxis operating on city streets. In addition, we've seen a strong push for autonomous technologies in the delivery and logistics markets, particularly to support business continuity in a pandemic scenario. And that can be evidenced by the recent, the major deal Amazon and Zoox have done to allow Amazon to acquire autonomous system technology. So we've seen a lot of, despite the disruption, lots of new opportunities for autonomous vehicle technology in the market. However, because of the constraints, organizations are not only have to innovate at the product level, but they have to take an innovative approach to product development itself, so the development process. When we look more specifically at the challenges facing the automotive industry developing autonomous systems, one of the biggest barriers to wider adoption is high system costs. And that is not only related to the high per unit costs of autonomous systems, but development costs themselves are prohibitively expensive for this kind of technology. It requires much more software content. It leads to greater complexity, longer development and test cycles. It's true to say traditional approaches for development and test don't scale well for these kind of programs. Reliability is equally a significant challenge when it comes to autonomous systems. Delivering reliable self-driving technology which is capable of operating in diverse on-road and off-road conditions, in diverse weather and traffic, and also being able to cope with the typical wear and tear in the field remains a significant unsolved technical challenge. So an important question arises. Is it possible in an era of reduced R&D budgets and intense competition to accelerate technology development while driving costs down and building better quality products? I'd like to offer some perspective from our side, from Cambridge Consultants' side, which we've learned in recent technology development projects we've undertaken. So we're often, in fact, challenged by our clients in finding breakthrough solutions to address these very challenges. And how do we do that? So first of all, alongside the traditional development approach, we see the role of simulation-aided or simulation-based development as critical to iterating, testing, and validating at more quickly and at lower cost than traditional approaches. Automation of the development tasks themselves is also an important factor to achieving these objectives. We've used adversarial testing approaches in some of our most recent projects to generate great quantities of test data sets, which we then use to improve the performance and reliability of our autonomous systems. Additionally, tackling the system cost challenges at Cambridge Consultants, a significant or an important technique we found is applying sensor fusion. So taking readily available off-the-shelf technologies, combining that with novel algorithms, AI and non-AI, allows us to achieve dramatic results for our customers, for our projects, at a fraction of the costs of traditional systems. And one final point on system costs. As AI content becomes more important in our projects, and as AI technology itself matures, we're able to move away from general purpose AI compute, so GPUs and FPGA platforms, and move toward dedicated inference accelerators from our partners at ARM and NVIDIA, which allow us to deliver AI at a fraction of the cost of the general purpose compute. So those are a few insights from our perspective in terms of achieving the goal of accelerating technology development, improving reliability overall. So in summary, development of autonomous systems requires deep expertise in the technology areas you see here, because there's a complex interplay between these technologies. Those projects can be complex and very costly to develop, test, and validate. And so embracing a simulation-aided development approach and introducing automation in the development process itself is critical to balance the schedule costs and reliability constraints that organizations are currently facing. As an example, in the automotive industry, what that means is while it costs $2 per mile of testing autonomous systems in the automotive market, with the simulation-aided development approach, it's possible to reduce that cost down to less than 10 cents, so a significant saving. Now, I'd like to go and offer you a specific example of a recent technology development project we've undertaken where we've been able to employ these very techniques to achieve a cost and time saving. But first, let me explain a little bit more about depth sensing. So depth sensing itself is an essential ingredient for any autonomous system. The ability for an industrial robot or an autonomous vehicle to be able to predict depth accurately in the real world is essential to allow it to navigate around obstacles and hazards in the real world. Those depth sensing systems traditionally are based on LiDAR, quite expensive and bulky, and cost many thousands of dollars, so making them unaffordable for many applications. The challenge for our team developing our EnfuseNet technology was to create a novel AI technology which could generate high-resolution depth data at a fraction of the cost of typical depth sensing systems. The model combines the output of a low-cost camera and radar to deliver an accurate depth point for every pixel in an image. And in an additional measure to improve reliability, the model offers a confidence score in all of its predictions. In terms of accelerating development, by using a simulation-aided development approach, we were able to move from typically what might take 4 to 5 months. For the EnfuseNet development, we were able to achieve our objectives in less than 2 months. So a significant saving in time and cost, but still delivering dramatic performance results, which you can see on the right-hand side, EnfuseNet operating on some real-world camera and depth sensing data. And at EnfuseNet.com, you can see the EnfuseNet model operating in a simulated environment. So, in summary, despite the recent COVID disruption, the opportunities for autonomous systems have increased in automotive and other markets. However, in an era of constrained R&D budgets, these opportunities, to secure these opportunities, organizations have to rethink their approach, the approach to development. Embracing the technologies we spoke about earlier will allow organizations to innovate more quickly at much lower costs and engage more early with their clients. And that certainly is a recipe for future success. So thank you very much for your time.